Okay, we're in section 129.3, and we're going to look at the exercises. And this one over here, it's, just find all the roots of. I'm going to go a little more detailed than just finding the roots of these things over here. There's a variety of ways of doing it. Don't think there's one way to do anything. I'm going to go to the whiteboard. I'll write the function down. The function's as follows. F of x, and let's review things we've done in the past. Not that I'm going to do everything we've done in the past, but looking at this thing over here, plus 3x, plus 9, all right? And, certainly things I could do with this is just get a general idea about what this thing is going to look like by taking its derivatives. Now, by the way, I know it's a cubic polynomial. I know it's going to sort of look like this over here, all right? And sort of like that. So taking the derivatives might be somewhat helpful. And it's going to be 3x squared minus 10x plus 3. All right, I'm going to put the second derivative down. And usually the first and second derivative, it can be helpful in understanding what the curve looks like. So this is going to be 6x minus 10. I'm going to be analyzing these derivatives on a number line for sine. This is f prime of x. I'm going to factor this. Let me get my eraser out too, so I want to erase something here. Again, we're just reviewing things we've done in the past. So what do we got here? Let me just get this down. 3x and x, 3, 1, minus, minus. I'll check it though. That gives me 3x squared. That's good. Minus 9 minus 1 is minus 10. Yeah, works good. So the roots of that are going to be at plus 3. And the other root I get there is going to be 1/3. If you analyze the sign, like after 3, you pick a number like 4, plugged it in, you get plus plus, which means the function's increasing here. If you go between 1/3 and 3, you choose 1, you're going to get, I'm just testing the signs out, and you're going to get, let's see, 1 would give us plus minus, which is negative, which means the function's going down. All right? All right, let's keep going. Let's try 0. What do you get? A negative times a negative, which is positive. So I'm pretty comfortable I got something like this. Now someone says, why would you go that level of detail? I have a pretty good idea now that this function is going to look sort of like this over here. Again, I'm not sure exactly, but I do know there's a point here and a point here. And the point here is going to be 3. This is the function f of x. I do know the point over here is 1/3. All right? Again, we'll go back to a better picture later. And I'm looking at this and I'm wondering, what's the function's value at 3? I just plug it in. And you plug it in over here. So let me go through that with you. That's going to be 27 minus, well, what do you get there? You get 5 times 9, which is 45, plus 9, plus 9. Well, lo and behold, you get 0. 27 minus 45 is minus 18. Yeah, you get 0. All right, let me erase my arithmetic. I don't need it anymore, just did it. Let me do the 1/3. All right, the 1/3 would be 1/27 minus 5/9 plus 1 plus 9. We're doing the third. All right, now certainly I'm going to do some arithmetic over here to find out what the number is. This is going to be 27. 1 minus 15. This is 10. I'm going to keep writing it down, by the way. This is 27 minus 14 plus 10. All right, so I'm going to add that together. Minus 14 over 27 plus 270 over 27. So what are you going to get there? 256 over 27. All right, just getting a rough idea what the picture looks like. We'll understand the roots better too, by the way. Okay, let me just get my eraser out. By the way, they did not ask for these points over here, but kind of looking at the picture now, what do I notice about this thing over here? This is a relative min, and this over here is a relative max. All right, there's also going to be a second derivative that I'm looking at, and I'll write that down on the side over here. And what does that take on a 0? At 10/6. That's 5/3 though, right? Pick a number after 5/3. I don't know, like 10. It's positive. Take a number below 5/3, like 0. It's negative. So what does this kind of tell me? Concave down, concave up. So I think I can put that down now. Again, I'm not saying I'm doing a terribly good job of accuracy in the scale, but that doesn't matter to me. I'm just getting a feel for the picture. 5/3. You know what I'm going to do? I'm not going to evaluate it. And I always take a risk in evaluating something and doing it wrong. I'm just going to say f of 5/3. And what's this thing over here? It's a point of inflection. I'm also going to erase this because I realize it really doesn't add much to the problem. I'm just going to say f of 1/3 there as well. Right, point of inflection, POI. That's where the concavity changes. Now, someone's going to say, they didn't ask any of those questions, and I'm not saying they did. Right? What they're asking about is, they're asking about the roots. And I know a root. And what root do I know? I know the root is 3, 0. So if I know the root is 3, 0, I could get the other roots. I'll write this down for you. F of x. Well, the root's 3, 0, right? Now, before I go on, I want to point out it's going to be x minus 3. But I know something about this root. And what I notice on both on the left and right side, it's not going through there, is it? So it's a repeated root, a square. What's left over here? Something. What is it going to equal? Well, let's write down what it equals. It's supposed to equal x cubed minus 5x squared plus 3x plus 9. Well, I think I can figure this out. This is going to be x squared, without doing long division, by the way. X squared minus 6x plus 9 times some linear factor, right? What's linear factor going to be? Well, it's going to be x plus some unknown number. I'm just going to call it, I don't know, call it a for the sake of argument. Right, what does it equal? X cubed minus 5x squared plus 3x plus 9. Well, you know what? I think I know what the a is. I'll write this down for you. Fairly simple. The a would have to be 1. And why is that? Let's go through that. X squared times x is x cubed. 9 times 1 is 9. Let's just verify this and see if it is true. What do you get? X cubed minus 6x squared plus 9x plus x squared minus 6x plus 9. If you add that together, what do you get? X cubed minus 5x squared plus 3x plus 9. Exactly what we're expecting. So I found the other root. Now what's the other root going to be? Minus 1, 0. All right, so we did quite a bit of analysis there. Now, if you look at the actual function itself as I'm drawing it out, you should admire those points that we put down, all right, including the point of inflection. You should look at the grid graph I'm giving you, point of inflection, the relative maximum, the x-intercept there, the x-intercept over here, and the relative nature of that x-intercept here, where it's not going through, it's a repeated root, all right? And that's kind of an important fact over there. It's repeated, all right? That's about it. I mean, there's certainly we did a lot of detail there. If you look at the notes, there's more detail down, but the bottom line can take this generalized strategy to do the problems. Thank you.